Session. I hope you have seen your previous session related to horizontal curves. I gave an introduction about horizontal curves, how this centrifugal force will affect your vehicle to either overturn or skidding. So we have seen to avoid overturning how the body dimension should be, that b by 2 should be greater than or equal to v square by gr, and also to avoid skidding how your friction should be greater than your v square by gr. Okay, and also we have discussed about that v square by gr is the centrifugal ratio, which is like an applied force which will make your vehicle to either overturn or skid. So to avoid an overturning, we cannot always have our body dimension to be in the sense of b by 2 or something like that. Okay, so to support the overturning, we are going to introduce a concept called super elevation. Okay, so coming to the super elevation, it is a traverse slope. Means, so far I hope the road, whatever you have studied was something like this. At the initial part of the videos I already introduced something called camber, which is something like this. Yeah, so we are going to raise the middle of the road surface in the case of camber. Yeah, so now the point of super elevation is we are going to raise the outer edge of the road surface something like this. The road surface was something like this, and we have raised the outer edge of the road surface. Okay, we have raised the outer edge of the road surface to help the vehicles to avoid the overturning. Okay, so remember one statement: the centrifugal force in vehicle will always act outwards, so trying to topple your vehicle. Okay, so always there will be a, whenever your vehicle is traveling in a horizontal road, okay, so it will always there will be the outer wheel will be experiencing the high pressure. The pressure will be very high because of the load, more load is acting on that tire compared to the inner wheels. Okay, so coming back to the super elevation, we will see in detail in the next 2 or 3 slides how this super elevation will help us. So remember, the super elevation is nothing but the slope is nothing but tan theta. Okay, so if b is the total width of the road, slope is nothing but e divided by b. Okay, so this is one of the basic definition of super elevation. In highway engineering, we say this slope as a super elevation, but in railway engineering we often says this capital E as a super elevation. Okay, so we will see in railway engineering that in later part. So coming back, I hope I made you clear that super elevation, we are using the super elevation, we are going to counteract the overturning. So to counteract that, super elevation is nothing but we are raising the road surface. How we are raising the road surface? We are by raising the outer edge of the road surface with respect to inner edge or with respect to center line. That we will see that also later. So in that way, we are going to counteract the centrifugal force. I will show you in the next slide how I am going to counteract that in the next slide. Okay, so remember, we are going to use this formula at the climax of this chapter. At this session, you will know this E plus F. I hope you already know that V square by GR is the culprit guy whom we are trying to counteract, correct? So now we are going to, already I have showed you E is nothing but a, small e is nothing but a tan theta. So with tan theta and coefficient of friction, we are going to counteract that V square by GR. Okay, so this is the introduction, and please pause the video and you can note down the definition of the super elevation. Okay, so coming to the derivation, you see I am going to derive a super elevation. I am going to show you that how this E plus F equal to V square by GR came. You see the figure. So this is the road. The road has been raised with respect to outer edge, and already I told you the centrifugal force also will be acting towards outside, and since I am raising the road surface by a term called theta, so which is nothing but equal to 3e, sorry, so the tan theta, since I raised with respect to theta, this weight component, you see if I draw an axis with respect to horizontal, something like this, so the vehicle angle has been shifted, correct? So this even this w also will w component also will have a sin theta, and w sin theta cos theta will be coming down. Similarly, p sin theta will be coming down. Correct? If you resolve, I hope you know how to resolve forces. So the step 1 in the derivation is I have raised the outer edge. Because of the raising of outer edge, you should know the free body diagram such that the w sin theta is going away and p cos theta is coming away. Okay. So from this figure itself, the step 1 you should agree that p cos theta is the term which is going to overturn your vehicle. Okay. So which is going to overturn your vehicle. Our job is to counteract this guy. Now because of rising this wheel, rising this outer edge of the road, we got a new term called w sin theta. Correct? So this term was not available earlier, right? Earlier when the road is straight and the vehicle is going something like this, so in a horizontal curve where there is no super elevation, obviously you can see p equal to w. Sorry, no, there is no p equal to w. P was creating a overturning and w was not helpful at all because w will act straight down. Okay, there was no component of w which was helping us, but when you have provided a super elevation, you can see the w sin theta term is helping us in opposite direction. You can see the w sin theta is coming in opposite direction of p cos theta, which help us to counteract the p cos theta, which is going to overturn your vehicle. Okay, so I think I made you clear how the w sin theta. So this is what super elevation is. By raising the outer edge, we will get a new component of weight, which is called w sin theta. The w sin theta will be helping us in avoiding the overturning. So this is the definition. So let's derive. Step 1, you can also see the forces. There are frictional forces available here. So let's take the tire A and let's take tire B. There are other frictional forces also here. Frictional force in tire A and frictional forces in tire B. Okay. So there are two. I hope you have. There are three forces: centrifugal force, weight, and frictional forces acting in the tire. Okay. So resolving the forces, summation of h is equal to 0. I hope you know the equilibrium of forces. Summing all the horizontal forces is equal to 0. So you can see p cos theta is going this side. Correct? Since p is going this side, friction will be acting in opposite direction. So I have added. You can see the figure now. You can pause the video and see the figure. This statement is valid. P cos theta is counteracted by w sin theta plus f of a plus f of b, and we know p sin theta is coming down and w cos theta is coming down. Correct? So frictional force f of a can be written as frictional coefficient into w cos theta, and frictional b can be written as frictional force into p sin theta. So taking the frictional component common, then we will have w cos theta plus p sin theta. So this is step 1, this is step 2. I just substituted in step 2 there are frictional coefficients. Okay. So step 3, divide left hand side and right LHS and RHS by w cos theta. Then we will have, you have to do some algebra. So if you divide w cos theta, then we will have p by w on left side and w plus f 1 plus p tan theta. Correct? Okay, I'm doing something, so I have to clear the screen. You can note down the figure, actually something like this. I have to clear the screen. So you divide by w cos theta, try to do some algebra, bring in left p by w on one side, you will have this equation. Then bringing that 1 minus f tan theta on right hand side, you will have this equation. So you should know that the super elevation will be normally in the range of less than 4 degree. You won't have the super elevation 30 degree and all. It will become a steep terrain, right? So the theta will be less than 4 degree and the coefficient of lateral friction will be 0.15. In that sense, if you substitute in 1 minus f tan theta, so you will have the value approximately 0.99, which is approximately 1. So then you can consider the denominator as, okay, tan theta plus f. So the denominator can be considered as 1. So this statement can be written as, you know, tan theta is nothing but E and friction is F, and P by W is nothing but V square by GR. So centrifugal ratio. So this is how you got this answer. So now we have derived a term using the W cos sin theta, but just raising the outer edge we got a term for counteracting that V square by GR by using super elevation slope E and coefficient of lateral friction F. Okay, so this is the story of with that the derivation is over. I am going to give some specific cases of super elevation. You can see when you are traveling in a straight road, when there is no super elevation, we know the centrifugal force will be acting outwards, right, in a level road. Okay, but still we are in the curve. When you are traveling in a level road over the curve, the centrifugal force will be acting outward. So there will be a pressure, high pressure acting on the outer wheel compared to the inner wheel, obviously. Okay, so similarly when you are traveling in a super elevation also, exactly same story. So the outer wheel pressure will be greater than inner wheel pressure, but there is something called equilibrium super elevation. Okay, so when you are having a equilibrium super elevation, we are going to assume frictional force equal to 0. If you are assuming frictional force equal to 0, if you remember, I have given two terms for FFA and FFB when you are deriving. Frictional force in a tire A and frictional force in tire B, both will become 0 in such a way that pressure in both the vehicles should be same. Okay, so when the vehicle is trying to overturn, the W is the only component because the frictional force is 0. Okay, so this is called equilibrium super elevation. Okay, equilibrium super elevation means we are going to find a super elevation. Okay, equilibrium super elevation. Equilibrium super elevation means we are going to find a super elevation in that way the friction component will be 0. If the frictional component is 0, both the wheels will be having a equal amount of pressure. Okay, so pressure on outer wheel will be equal to pressure on inner wheel. So in this way there is no friction. We can determine the super elevation by just substituting F equal to 0 in that formula. Okay, so this is one of the case, and case 2 is if there is no super elevation due to some practical reasons. Consider there is no super elevation at all, means like a normal straight road, then E equal to 0, right, then total V square by GR has to be contracted only by the friction. So remember this too. So consider in a level road there is a horizontal curve, but nobody has provided a super elevation, then the total V square by GR which is coming from outside like an external term is to be contracted only by the friction. Okay, and no, it's not equal to 0, it's if E equal to 0.07. so IRC, actually we will see in coming 1 or 2 slides, IRC has suggested maximum slope or maximum super elevation you can provide is 0.07. okay, not more than that, like 7%. so if super elevation is 7% and maximum friction we have already discussed in detail, maximum friction IRC is suggesting is 0.15. then if you see E plus F equal to, we know V square by GR, so this will give you the allowable speed, right. So you just substitute 0.07 plus 0.15, this will give you 0.22, then V will be equal to square root of F, not F, this should be something like 0.22 into GR. okay, so actually this is not F, so this should be 0.22. so if you substitute a radius value under 9.81, this will give you the safe traveling speed. Okay, or this will give you the maximum speed you can travel, because they have already provided the maximum super elevation and the maximum friction. Okay, or this will give you the you can say is a restricted speed also, because this is the maximum. If you go beyond the speed like 80, consider the answer you are getting is 80 km/h. Consider you are traveling in 90, for particular 90 km/h the V square by GR will be very high. You can see this formula. Okay, but the E plus F whatever you have provided is only 0.22, so your vehicle may overturn. Okay, so to find the restricted speed, at what speed you should travel so that you won't overturn, is using this formula, V equal to square root of 0.22 into GR. Okay, so this is some specific cases of super elevation. and this is not the super elevation cannot be used directly using a formula. So this should be designed. Okay, you cannot randomly put some numbers. So this our procedure of determining this E is given by this slope is given by IRC. So what they advised is step 1. I have some 3 steps, you can just follow this. Step 1, to find a super elevation in a mixed traffic conditions like India, we are following a 75% of design speed. In a country where they have a sparse population, they will have all the vehicles traveling at design speed. So in a mixed traffic flow conditions, so mostly nowhere all the vehicles can traveling at the design speed. So there will be always a mixed traffic flow, like in any roads, like in your city routes also. So you cannot have all the vehicles traveling at 60, all the vehicles traveling at 50, right? There will be possibly a mixing of traffic flow, somebody 60, somebody 40 km per hour, somebody 30. So in that case, for designing a super elevation, IRC is suggesting the step 1 is neglecting the friction, means F equal to 0, in that our A plus F equal to V square by GR formula. Assume friction is equal to 0, and then also assume 75% of the design speed, which is nothing but 0.75 of V. So using substituting that both the things in this, you will get a particular super elevation. So you are finding the super elevation if there is no friction at all, how much super elevation is required, okay, for a mixed traffic flow condition. That's what you are doing in the step 1. You can replay the video and here. So if you are getting the answer less than 7%, then no issue at all, you can provide the super elevation whatever you got, okay. So the problem is over, the design over by here, okay, understood. If your answer is less than 7%, then provide that super elevation, go out, that's it. If your required super elevation means the people who are coming in very high speed or the radius is very small, then the required super elevation will be more than 7%, then you have to include the friction also, okay. Step 3, then I am going to step 3, okay. So I am going to find the what is the friction required, although assuming maximum super elevation, okay. So in this formula, I have to find the friction providing the maximum super elevation. You can see this formula, how this one came. I just brought the E max because already it is crossing the 7%, right? So substitute everything in this formula and then find the friction. If your answer of friction, whatever the friction required is less than 0.15, then it is okay. Provide the super elevation of 0.07 and get out. If your answer is less than 0.15, means to counteract the overturning, we are now asking the help of friction. If the friction can help, maximum up to 0.15. So if your requirement is less than 0.15, then it's okay. Provide the 0.07 and close the problem, okay. Else if your required friction is more than 0.15, then you cannot do anything because already you have provided maximum super elevation and already you have considered the maximum friction also. So then you have to go to step 4. So in step 4, we are going to find the allowable speed, because consider there is a horizontal road. You are going to provide some speeding condition, like something like 45 or 50 or something like that. You are going to put some speed limit to show that although you have provided the maximum super elevation, maximum friction, this is the speed you are getting. So you are going to show to the people that my road is designed only for this particular speed, okay. My road is designed for the maximum super elevation, maximum friction. You can travel only at 50 km per hour, something like that, okay. So this is the step 4. Even in step 4, you are going to provide the maximum super elevation of 0.07 and show to the people that the restricted speed is this much, okay. So step 1, you can pause the video and re-listen, but step 1, you find the super elevation neglecting the friction, okay, and you are checking that whether it is less than 7% or not, okay. If it is less than 7%, provide that percentage, else you are going to ask the help from friction. So friction is coming and helping us and he can help us only up to maximum 0.15. Although, so you are going to see the requirement. If your requirement is less than 0.15, then it's fine, provide the 7%. Else, if the friction requirement is coming more than 0.15, you cannot do anything, because friction also provided his maximum help, and super elevation like you also, you have provided the maximum of 7%. Clubbing both, you cannot have a the same speed. Okay, so you are going to ask the drivers to drive very slowly at the speed rate of square root of 0.22 into GR. Okay, so this is the procedure for designing a super elevation. You have to design whenever they are asking you to design super elevation, also you have to design. And also in the case of length of so there is some chapters about to come, transition curve. In that transition curve, the second class will be you have to find the super elevation. In there also you have to follow this design procedure. In these two places you have to follow this procedure for solving the problems. Okay, and as I was discussing earlier, for plain and rolling terrain, IRC has suggested maximum you can use only 7%, and for hilly terrain you can go up to 10%, where there is a urban roads with so much of frequent intersection, something like this. Okay, so consider there are so much of intersections are coming in the road, then you cannot have a different super elevation. So they are asking you to maintain only 4% for the frequent intersection. Okay, and in the horizontal curves they are asking at least minimum provide 2 to 4% for the drainage purpose. So they are asking at least 2% rise in the outer road surface or some for drainage purpose. Okay, so please note these values. Okay, so now how to attain the super elevation is, you can attain the super elevation by two ways. Okay, one is by I hope you remember now, there is something called camber, right? This camber can be located or shifted towards outside. That is one way. See, first way is elimination of the crown of the camber. That can be done by two ways. One is shifting of the crown point, of camber towards the outer edge. Second, in the same camber you can fill the material and make the camber go away. You can that is the figure I have shown here. Okay, so the elimination of crown can be done in two ways, as I discussed. You can shift the crown point, or you can raise the outer edge to match with the camber point. Okay, so this is one way of attaining the super elevation, but very common way is the figure I have shown here. Okay, to have consider this is straight road, I need a super elevation. So to have a super elevation with respect to inner edge, it's very that's very common. This is very common. Okay, I will raise the outer edge. Consider this is the outer edge. I will raise the outer edge with respect to inner edge. This is very common. Or you can have raising the inner edge. Okay, you can raise the inner edge. So our purpose is only to have a theta, right? Our attainment of super elevation is nothing but I need to have the theta or super elevation in the road. So if I raise outer edge also, I will have that super elevation. If I raise inner edge also, I will have that super elevation. Or if I rotate with respect to center line, see, this is a straight road, I will do something like this. So rising like this, lowering like this also, I will have the same theta. So there is three ways of attaining the super elevation in the case of rotation of pavement. Either I can rotate about center line, or I can rotation about inner edge, rotation about outer edge. Rotating about inner edge is not common and it will give negative super elevation. About outer edge is very common and this is rare. Okay, and if somebody asks you in 1 mark for elimination of crown, you can say, see, they have shifted the crown. So they have the crown point was here, they have shifted the crown to the point where the super elevation is required. Okay, so we can attain the super elevation by this two ways as we discussed. Okay, so you can pause the video and note on this. If somebody asks you for 1 mark, you can use this. This rotation point will again come in. We will see 1 or 2 problems in this, and also we will this is very rotation about pavements will be very useful in transition curve problems. Okay. Okay, so the final topic you should know is the radius of horizontal curve. I hope you know the formula. Now E plus F equal to V square by GR. Okay, So if consider they are asking you to design the radius, now you have to design the radius of the horizontal curve. Now we have only this formula. So we know the maximum super elevation can go is 0.07 and maximum friction it can go is 0.15, right? So this will give you 0.22 is equal to V square by GR. So if we know the this is the maximum value it can become, and you can see E and F is inversely proportional to radius. You can see that, right? So if E and F is increasing, the radius will decrease. So E and F is decreasing, the radius should increase. This is inversely proportional. And if this is the maximum value, this is the maximum value. The value E plus F will not go beyond this. So if you know the maximum value, if you provide the radius for that maximum value, then whatever the future expansion doesn't matter, right? Whatever happens from the future. So if they want to expand the speed, design speed of the site location, no issues, because we already considered this and we have designed the ruling radius. So when you are designing a radius, try to use the maximum values. Okay, if they are asking you the ruling radius, if they are asking you the ruling minimum radius, we can use maximum super elevation and coefficient of friction to obtain the ruling radius. So you can pause the video and note down the points here. So if you provide this 0.07 and plus 0.07 super elevation and 0.15, when you are substituting in this value, then you will have your minimum radius, right? So when you are keep on reducing, the radius will go height. See, this is the maximum radius. When you are providing a maximum super elevation, maximum friction, that is the minimum radius you will get, because inversely proportional. So if you are not providing 0.07 and you consider you are providing only 4 or 3%, then whenever you are reducing your super elevation or friction, your radius will obviously go high. So this is the term for this minimum. That's why I am telling you this is the minimum radius. When they are reducing the super elevation, your radius will go high from this value. So whenever the question is being asked for estimating to find a ruling radius, please use the maximum super elevation and the maximum friction. So this is a new concept other than super elevation, okay, in the horizontal curve. So this is very short. I will with this concept we will close this session. You can see there is a horizontal road. I wish to draw here. So consider there is a horizontal road, okay. You need to provide an extra widening. So whenever there is a horizontal curve, so you can see this is a circular curve. So this should be the road width, but we will provide some extra widening in the road for two reasons. One is for vehicle reasons, like a mechanical widening. So that the vehicle can easily take a curve, and another one for psychological reasoning. This is for whenever there is a fog or mist or something, or due to some personal human characteristics, people may forget to visualize there is a curve. So the driver tendency, they will fly away from the edge of the carriageway. So to avoid that, we are going to provide some extra widening in the horizontal curve to support both the vehicle and the driver characteristics. So how much we are going to provide is, you can see, we are going to, this is the actual width of the road, and we are going to provide some extra widening. Extra widening means we are going to provide some mechanical widening, mechanical reason and psychological reason. You see, mechanical widening, there is a derivation, you can refer textbooks if you want. This L square by 2R is also called as off tracking. Okay, L is the length of the base of the vehicle. So whenever there is a, if you see, whenever there is, consider you are having a running race. So this is your track. So when there is a horizontal curve is coming in your track, if you are going away from your track, this is called off tracking. You are going off the track. Okay. So how much your vehicle, consider there is a vehicle, how much when it is going to turn, okay, how much it is going to use the other lane also. How much width of the road it will use from the other lane, so that it will go off track. So that depends on the number of lanes also. Okay. So based on that, we have derived this formula, NL square by 2R. So if they are asking you For off tracking, just use the formula. Off tracking will be for only one lane, because one vehicle will not take 2-3 lanes. So if they are asking for off tracking, just use L square by 2R. But for extra widening problem, just use N. N is the number of lanes. If it is 2 lane road, 2, 3 lane road, or 4 lane road, put 4. L is the length of the base. Mostly it will be around 6 to 7 meter, and R is the radius of the horizontal curve. Okay. Psychological widening, V is given in meter per second. Okay, and R is in meter. So this is an empirical relation given by IRC. You just substitute these values, you add this one. Mostly this extra widening also will be in the range of 0.6 meter to maximum 1.1 to 1.2 meter. So this depends on site condition. Only with this will be your range. You won't have extra widening itself like 7 meter or 8 meter. Okay, so this will be in this range 0.6 meter to 1.2 meter, depends on the number of lanes and radius and speed of the vehicle. Okay, so this will give you the total width. If they are asking the total width of the pavement, you should add both width of the road. If it is 2 lane road 7 meter, 4 lane road like 3.5 into 4, that total width plus this extra widening you should add. So that will be the total width of the road at the horizontal curved section. Okay, so this completes horizontal curve theory. So you should learn, you should know what is super elevation. I hope in this session we have learned what is super elevation and how to attain that super elevation, and what are the how the formula came, E plus F equal to V square by G, or how that formula came, how the W sin theta is helping us to counteract the overturning, and what is the design procedure for super elevation, and what is the minimum and maximum super elevation. And then we have introduced the concept of extra widening to help for the mechanical reasons and psychological reasons, and we have introduced the formula for them. Okay, so with this I will close this session, and we will solve problems in the next session. Thank you.